OK, so here's a good one. I have 3 divided by 4x minus 2 divided by x squared. And a lot of times students will get it when we get with numbers. They say, OK, I can find the LCM between 2 numbers. That's pretty basic. I've been doing that for a while with fractions. But now what do I do when I have a 4x and a x squared? So a couple things we need to look at. Let's just look at the numeric LCM. So I look at here, and you can say that this has a 1 in front of it, right? So between the 4 and the 1, the LCM is going to be 4. And a lot of times what I like to do, and I'm getting a little difficult with determining the LCM, I'll write it off to the side. So I say the least common multiple between these two is going to equal 4. Then we look at the variables, all right? And you notice that our variables are not the same. Here is an x, and here is an x squared. So the smallest variable factor that they both divide into has to be larger than x, because x squared does not evenly divide into x. However, x does divide into x squared, and so does x squared. So therefore, my LCM is going to be a 4x squared. Now what I need to do is just determine what values do I need to multiply both my denominators by to get to 4x squared. So here I already have a 1x squared. So therefore, I just need to multiply by 4. And whatever we do in our denominator, we're going to do in our numerator. Over here, I already have 4x, but I just need to multiply them by x to produce x squared. So therefore, that will give me now a 3x over 4x squared minus 8 over 4x squared. And therefore, now we can combine these. However, now we can combine them because our denominators are exactly the same. However, our numerators do not have the same variable factors. They're unlike terms. So I'm just going to have to rewrite this as 3x minus 8 over 4x squared. And if we want to write a constraint, we know that our denominator cannot equal 0. So one thing that we do to write our constraint is we just set our denominator equal to 0, because we want to find what values make it equal to 0, because that's what's not going to be a part of our solution. So we solve for 0. Or we solve for x. So therefore, when x equals 0, our denominator equals 0. So therefore, our constraint is x cannot equal 0. And there you go, ladies and gentlemen. That is how you subtract with unlike denominators. Thanks.